How do free body diagrams help provide a visual representation of the forces acting upon an object? Regardless of whether or not an object is in motion, there are a number of forces acting upon it at any given moment. Take this book, for example. Gravitational force is keeping it from floating up off the table, and normal force is preventing it from just falling straight through the table. Let's say the book was in motion. If I started pushing the book, it gets even more complicated. Now you must take into account the applied force of the pushing being done by my hand, and also the force of friction between the book and the table acting in the opposite direction of where I'm trying to push the book. Now we have a problem. We just named 4 forces acting upon this poor copy of Hamlet and no way to visually represent it. That's where free body diagrams come in. Since we're only concerned with the forces acting upon the book itself can just be represented as a dot, and the forces acting upon the book can be represented as vectors emanating from the dot and pointing in the direction in which the force is acting. Also be sure to label what your axes represent. This free body diagram represents the forces acting upon the book while it's actively being pushed by my hand, not including when my hand initially pushes the book from its still position. For the sake of this example, we'll say the book is being pushed at a constant velocity. You'll notice that applied force is acting in the positive x direction, and friction is acting in the negative x direction. The 2 vectors are represented as equal because the book is moving at a constant velocity. Therefore, there's a net force and acceleration of 0 in the x direction. Normal force is going in the positive y direction, and gravitational force is going in the negative y direction. These 2 vectors are represented as equal because the book is not moving in the y direction at all. And there we have our nice, clear visual representation of the forces acting upon Hamlet.